Modern game studios operate under an intense, compounding pressure. They have to deliver polished, multi-platform experiences and a constant stream of updates to meet massive player expectations, almost always while navigating tight budgets and timelines. When a team struggles to meet these demands, the instinct is often to blame a lack of raw coding speed. But typing faster doesn't actually solve the problem. The real enemy is drag, the friction of constant context switching, deciphering vague design specifications, and untangling dense code dependencies just to see how a single change ripples through the game. This diagram shows a standard build, test, learn iteration loop. Because of that drag, the build phase distorts and consumes nearly the entire cycle. Developers end up spending days constructing basic scaffolding just to see if one single idea works. The act of trying something out becomes too expensive. When experimentation is costly, innovation stalls, and developer burnout accelerates. The Unity 7 roadmap signals a shift in how developers interact with the engine. It focuses on a change in workflow rather than a specific rendering feature. This animation contrasts two different AI models. Treating AI as an external plugin forces a developer to leave their workflow to ask for help, introducing heavy friction. Unity 7 treats AI as a native collaborator, woven directly into the engine's core environment. Because this native layer sits right inside the engine, it understands the full context of a project. It bridges the gaps that traditionally separate art, engineering, and design into isolated silos. Embedding this assistance directly into the engine's lifecycle targets the root causes of that friction. The iteration loop compresses. Practical AI in game development focuses on the quiet, daily compression of workflow timelines. Historically, prototyping a new mechanic meant losing days just wiring the basic inputs and building temporary frameworks before you could even move a character on screen. This timeline comparison illustrates the shift. An AI assistant drafts a functional baseline in minutes, collapsing days of setup into a single hour. Developers can then use that time to validate the design and figure out if the mechanic is actually fun to play. This same friction reduction applies to later stage work, like triaging persistent bugs and implementing UI changes. Traditional debugging often relies on manual guess and check. Developers have to dive deep into the codebase to trace exactly how a minor UI tweak might break a seemingly unrelated system. Here, a native coding agent acts as a searchable assistant. It maps the dependencies, surfaces the most likely cause, and proposes a safe, reviewable first-pass fix. Vague tasks like make movement feel weightier turn into structured, immediate actions. The entire journey from prototype to playable build accelerates. While this shift impacts every creator, it targets different structural problems depending on the size of the team. Solo indie developers gain leverage. They can patch specialist gaps, like generating routine glue code, and maintain high iteration speed across multiple disciplines without having to hire a larger team. For large studios, the bottlenecks are often coordination chaos and the loss of tribal knowledge. In a massive project, coding agents serve as a queryable repository of the project architecture. They help new hires onboard quickly and keep parallel feature squads aligned on the same coding standards. Whether it's one person in a bedroom or hundreds across a campus, this workflow layer allows creators to increase their creative surface area without scaling the chaos. This shifts the engine toward intent-driven iteration. A creator describes a desired outcome, and the tools generate candidate changes for human review and tuning. However, treating AI-generated output as a finished product is risky. Slipping unreviewed code into a project can destabilize the architecture, creating immediate technical debt. Engineering discipline remains the priority. Effective teams treat AI assistants like a junior developer's output, requiring rigorous profiling, documentation, and a final human sign-off. This acceleration builds a compounding advantage. When prototyping is cheap, teams can test radical ideas earlier, building a deep well of project-specific insights long before the final push to ship. By targeting the friction points that stall production, Unity 7 shifts the developer's focus from repetitive maintenance toward high-level iteration. The value of a team becomes tied to how many creative decisions they can validate in a single week.